I'm Philip Ong, geologist. I'm here with Mr. Dane DuPont. I'll be manning our streams and the chat and the comments for you guys, taking some questions. We'll take some questions here at the end of our broadcast, but we know there's other things happening in the world today, so we want to make this quick today for you guys. Still, we're going to cover Kīlauea's ongoing summit eruption, 2020 to 2021 eruption, now on day 17. And start off showing you guys here this video taken from the USGS showing what began as that entry point right there, where the lava was coming into the surface, under the surface of the lava lake. The lava lake's edge is right over here. The lava's coming in underneath, and it's kind of bubbling up, right? So that was a couple of days ago, and this is a video from more recently. It's either yesterday or the day before, showing a much taller lava fountain that they're calling a dome fountain right here. So you can kind of see some spattering activity here on the edges. You can see they're zoomed in a long way with their telephoto lens, and any little wind makes the camera shake. So some parts of this video are pretty shaky, but you guys can still appreciate. They're saying here, I'll wait for to zoom my head a little bit here, so it's a little more stable. There it is. And you can see the crust here getting sucked back in, and all the spatter kind of landing over here. So there's quite a bit of movement going on right around this fountain. And here at the end, they say the height of the dome fountain is estimated to be 5 meters, 16 feet, with an estimated width of 10 meters, 33 feet. So I heard you guys' request to try to superimpose some things for scale on some of these images. We'll do that in some future updates. Today we're going to kind of keep going and keep it quick, right? So that's the most recent view of that dome fountain. You can kind of, we're going to go backwards in time now to January 2nd. And this is a video you can see in daytime, that edge of the lava lake here. Here is an old kind of rubble pile, right? That's kind of the edge of the crater here. And the lava, there's new lava covering it in this section right here. It's going underground, under the edge of the lava lake that's crusted over right over here, right? Other spots, it's actually created a little margin, and it's been flowing up and over the margin into those low spots around there. So that's kind of how it's evolved. We showed you guys in pictures before. We'll show you in pictures again. But I wanted to show you guys kind of in a video format today, kind of going back in time to the 29th to release this thermal time lapse. This is all USGS Hawaiian Volcano Observatory footage. We're just kind of showing it for you guys and trying to annotate it and analyze it a little bit. So you can see here these upper vents putting out all that gas, and then the lava stream coming out here, right? And on the 29th, we still had this open little channel coming through the bottom, right? So we didn't have a little dome yet. And it's because that thing crusted over. I'm gonna put that one back again. It's because this thing over here crusted over that we actually were forcing more of the lava to go underneath and kind of pop up, and that's why it made that fountain right over here. And so in fact, you know, when you have possibly a tightening channel for the lava to come out and error variations in the pulses of how much lava is coming out, then you can kind of see some interesting effects happen, and we'll get into that here shortly. But one last video to show you guys. This is back January 1st. This is a view looking down, so you can get a view of these upper vents over here with spatter coming out, right? Once in a while, that kind of Strombolian kind of activity. See, that one fell back in that vent, right? It's gonna get coughed back out at some point again here, or it might get sucked down the channel and put out the bottom over here. And you can kind of see big rafts of crust floating away, and that big spider pattern on a big scale. It's kind of extending from here. There's a nice little spinning piece of crust right over here. It's almost like a little eddy. And one on the other side as well, over there. So pretty amazing footage USGS is putting out here. You can really analyze how these pieces of crust are tearing away, right, on both sides. Kind of plate tectonics for all the geology students out there, right? But you also have these interesting rafts, little pieces of crust. Look at that one getting sucked in and folded under, right in there. And you can kind of see a wider angle view here, lava lake. And now we're zooming in on a spillover, right? So here's that edge of the elevated crust, above ground swimming pool, so to speak, and it's spilling over the edge. And you can kind of see the lava rushing out over the edge there, taking big chunks of crust with it right? And let's look at the size of this flow. So these things are pretty big. We just can't see them because they're so far down, out of the way, down on the bottom of that crater. But it's pretty amazing footage to see here. And the actual edge is right there of that perched lava pond. All right, so pretty cool. And here is the most recent image released today. So you can kind of see that same western vent over here. Northern vent not quite drowned out over here. Our island, big island, is still positioned close to the vent, kind of maybe spun a little bit, and all the other islands, all the other 11 islands are all bobbing up above as well. So you can actually zoom in on this one quite a bit, and so let me go down here and show you guys a little bit closer, since some of you guys might be looking at this on some smaller screens. Here, let's make this a little bigger. And so you can see there's that little dome popping up, right? And the upper vent putting out all the gas, but still quite a distance above the surface of the lava lake, which has been climbing up. It's climbing up more along this inner perimeter, and occasionally spilling over the edges into the trenches over here on the sides, right? And with the kind of everything focusing into this one little nozzle and bubbling up in this dome fountain right over here. You guys can see there's a third spot over here that wasn't in any of our previous photographs that I have shown you guys so far in this broadcast, because this thing busted open not long ago, and it made an end a little path when there was too much pressure for it to fit in that little tube. So we'll look at that here shortly as well. Another thing to look at of note over here, island is looking mostly the same. At the northern vent, we're kind of keeping track on that as a measure of our rising lava level, and so you can still see it up here. You kind of see it's getting more submerged. You don't really see as much of the arms sticking out over here and over here, so we'll keep looking for that as we progress through. The view last night was this, so very similar as well. There's our island. You see a lot more glow of the lava lake glowing through the cracks in the crust. That is where it releases all its heat upwards, right, forming that crust. And that crust is moving around and drifting along with the island as well, and parts of it getting sucked back in, like you guys were seeing. Some dynamics and overflows. But the northern vent is still visible over here. And the western vent, you can see, had a glowing spot in the middle, but it wasn't quite open all the way at that point yet. And still quite a bit of glow coming out, and all the gas coming out the top over here. So moving on, latest statistics from USGS. The lake is 192 meters, 630 feet deep, 70 acres. SO2 still elevated, and reporting still lava flows from that mid-elevation vent, weak strumbling and spattering from the upper vent, and still the dome fountain at the inlet to the lava lake. All right, so the latest thermal imagery is looking like this. So our big island is drifting still. It seems to be doing another wiggle going back towards the south, right? And all these other little islands aren't moving very much. It's hard to tell on this kind of one-day scale, but if you go and look at our Post in Hawaii tracker of the whole eruption in 5 seconds, or also has a video of 1 day per second on there, you can kind of see some of these move a little bit more, especially over here. And of course, all of these were submerged as a mass at some point and bobbed under and covered in lava, and then popped back up and then kind of spread out in this area. It's something you guys can look for. Cool things in that thermal right over there. There's also a thermal image released by the USGS, taken from the helicopter. So you can kind of see the islands over here looking, we're having an opposite point of view. Right now our north is this way, our western vents over here, and our northern vents over here. You can kind of barely see the two little arms of it right in there. It looks like a Pac-Man. And you can see it looks like a circulation still going this way, right? And the USGS has referred to lack of any surface movement of the lava lake anywhere near this northern vent. So it seems like it really is truly been clogged up for a while now, and nothing is going back in the ground there. And no other features disturbing the lake surface anywhere around here or anywhere over here where there might be other vents as well. So, but that's kind of an unknown still, what's happening at those lower vents kind of buried under the lava surface and behind a field of view of the island right in here. All right. So here's a view of a small breakout in that western vent. This was taken during a helicopter overflight at 8 a.m. it says, taken by Mr. Carr, USGS, January 5th. So you guys can see, let me zoom in here. that there was another spot that opened up here, kind of along that path of the lava down to that dome, right? But it kind of had crusted over before that. At this point in time, it bursted open and is now flowing down in a little channel going into the lake, plunging right in there. So kind of the combined effect of this is like the overflow valve for what's going on underneath it. Probably it's still this. Combined are both going and feeding the dome, and there's a little entry point right in there as well. So those are the kind of most recent developments. The lava lake continues to fill. You can see it's still coming up here. I can probably refresh this and you guys can see that it continues coming up, right, slowly. We can expect it to be a meter a day. That's kind of the range of it, kind of a slow, steady climb here at the end. End of this flat graph over here. Looking at the USGS deformation data over the last 2 days, it's been mostly a downhill trend, but then a little bit of rebound today on a scale of 0.3 microradians, not very much really in the grand scheme of things. The trend over the last week, visible on the bottom down here, is more of a straight down, lost essentially 2 microradians over the last week, flattening over the last day or so. Here, so essentially the pressure has still been dropping over the short term, maybe a little bit less in the last day or so, but in the grand trend of it, and the scale of the whole eruption here for the past month, you can see that we came down a lot, lost a lot of that pressure, repressurized a little bit with a vent reconfiguration, and then we've been draining. The ground has been tilting back closer together, you know, at the surface, and that's what we're measuring here. Is that tilt of the ground, which is, we believe, indicating a pressure that's building underground or being relieved underground as the lava and the gases can be expelled through the eruption there. So that's really it. The GPS is not that much different from what I showed you guys before. It seems to have stabilized at the scale that we can see here. No new SO2 plot, but you know, we're told a new measurement is somewhere in that same range. Somewhere in here, we're not sure exactly what. Let me change my color so you guys can see that better. Right in here, our new measurement is somewhere in a range between here and here. I'm not sure exactly where, but still within a range of previous long-term eruptions of Hale-Ma'uma'u Summit Lava Lake, and so for that reason, we're still kind of keeping an eye on that as maybe a leading indicator of what might happen next. And so far, no signs of change on that. You know, no signs of change in the gas, but the pressure, as indicated by the tilt, seems to be decreasing slowly. All right, the tremor is still coming and going, so you can kind of see there's bands of more vigorous fluid movement, right? And kind of see on 2 different stations in slightly different ways depending on our distance. And so the gas is still coming out. I have to reload this Purple Air website here. Earlier this morning, I looked at this and there was actually quite a lot of greens. It's a lot greener than it's been here in the South Kona, and actually Kīlauea is a little bit more yellow and orange today, and some greens up here in North Hawaii, which is great because they've also been suffering from all the bad air has been the biggest impact, right? And it's been lingering more so in the last few days in this area, whereas in the first week of the eruption, it was more of an impact of the eruptions that were more immediately downwind right over here and more of the SO2. So it's interesting to see how that pattern seems to have shifted a little bit, right, at least on these reports here. So earthquake-wise, there are a few. We have our Pahala clusters still happening here. By the deep conduit of magma, you know, nothing to really tell us anything right there. We can't really link those with any kind of pattern in time, with anything to surface 30 miles away, both in depth and in horizontal distance. And on Kīlauea, we have, it looks like 1.6 is that one, and that one is a 1.8. That one is actually quite deep as well. And so is this. These are actually all quite deep earthquakes. So this is actually part of maybe that same feeder. Imagine there's some way that these things connect from here to here, and then they come upwards, right, to erupt, something like that. And from there, they kind of can make that turn and go down the East Rift potentially, but there's no sign of anything happening anywhere. Over here is the main point of it, right? A little bit of adjustment, a couple earthquakes in the south flank. So a couple final things here. There's a new DM map released by USGS here. You can kind of see this image right here on the right, and besides just seeing a change in where the island is, and it's kind of, you guys can go and look at it and look at the changes and how the islands have moved. Even the smaller ones you can see have moved. And those, right, the photos that go along with it. But I kind of want to zoom in here on this bottom part of it right over here, where we actually show this cross section, because this is kind of interesting to think about how we now have an island right over here, and the west vents are over here, and only in relation that these west vents are kind of a little bit above that block that's down here. Right, so there might be a spot that's deeper, that's a little farther away, and a spot that's a little bit shallower. So we're not quite sure how the circulation of this thing goes, right? We imagine it probably goes over and then probably down and around in some way like that, right? But if you have a deeper spot, maybe you have some more of a backflow in this area, rather than over here it can be more of an outlet. So I don't know, it's interesting to think about what that might actually mean when you release these kind of cross sections here. And of course, this thing is just on one part of it, right? It's not, it doesn't extend across the entire bottom of the lake. It's just one chunk on the side, although it's a pretty big chunk of land over there. So, okay, last thing is, we would like to bring you guys more of the USGS talks when they happen, but there's a postponement in the Volcano Awareness Month 2021 because of the ongoing eruption. So you can check out we're going to keep posting things in Hawaii Tracker, hawaiitracker.com. And Dane, if you want to hit us with some questions or, anything you want to say about our sponsors.
Yep. So again, thank everybody for joining us. We are brought to you by Hawaii Tracker at hawaiitracker.com. We are streaming to you live on YouTube, Facebook, and Twitter. And we're able to do this because of the generous donations of our supporters that enable us to keep going, basically. So we do have some new donations I want to pull up. 1 second. There we go. From last time, David O. and Mark D. with a monthly donation. There's 3 ways to really support us. The first is if you enjoy this type of content, you think it's relevant, to share it with friends and family or people on social media. Second way is to help us on hawaiitracker.com to either financially support or become a member and a user. And the highest level to support is through monthly donations, right? So when there's no eruption happening, we can continue the research and things along those lines to keep the content coming more frequent. And again, we thank everybody that has donated, and we'll get to some questions now. So we don't really have many today. We're kind of getting through it kind of quickly, but there's 2 that came up. Very similar questions. I'll ask the one from YouTube from Jay Roller. So and you've answered this one before, but we're going to do it again. So once the lava lake level exceeds the height of the vent, will it continue to fill the lake?
Yeah, it very well could. It all depends on the pressure and the pressure of the backfill as well. So, excuse me. So yeah, we could see a continual bubbling of lava into the lake if it has enough pressure to sustain that, and that kind of is why we're looking at the gas as a telltale sign. If the gas can be sustained, that's what's bringing lava up and through. So if the gas stays steady, then maybe it can keep bubbling into the lake from below. Many of the lava lakes in Kīlauea's past history have come up from below, although you kind of imagine that the longer a lava lake is in place, the easier it is to come up from below because it's kind of established a path, and the lava actually can erode and kind of widen that path a little bit at a time, as it kind of moves through there. And so it can do that, but until it reaches the very top of this thing that we're showing on the screen right over here. So these upper holes, it's just going to burst out the side like it did right over here. And whenever it can't get enough pressure out, it'll just do this kind of thing until it starts coming out the top over here. Eventually, if we get that long and that far, if there's enough gas to push the lava up, that's a lot of volume to get up to here, that extra, because the farther up you go, the crater is wider. As someone described as like an ice cream cone, right? So.
All right. This one's from Nathan, our friend from 2018. What's the chance of the lake just stopping filling up versus stay as it is versus the lake causing some kind of additional event? So, what's the probabilities in this, ballpark are we looking at?
Well, so
just generally speaking,
right? It's really hard to say because excuse me. So you've got to combine the supply levels of the magma to the volcano with the kind of collapsed structure of the volcano at the same time. So it's hard to have the right combination of having the post caldera collapse structure with like the supply rate that we imagine maybe hasn't changed since the Pu'u'o era. You know, I mean, you can kind of imagine if it didn't change during those times, and maybe that's what's kind of keeping things going. Or did it go up? But in that case, how much did it go up, right? And so we're imagining that we're relieving still built up pressure over the last 2 years of eruption, and that's kind of what's driving everything to come out, right? So that's really what determines how long it can possibly last. And so as far as it going anywhere else, I don't think it probably goes anywhere else because it can still find a path out upwards the way it is now. And if anything, it's establishing at least pathways that would be partway established, partway used for a long time. I would imagine even after the eruption ends, you can kind of imagine it. The lava draws back down into the crack, and it only goes down so far, and at some point it kind of stays molten, and open, right? So those weaknesses are kind of a long-term process of refilling the volcano. Did I answer that, Dane?
Yep, I think so. Final question here. Somebody's looking for a little bit of the conceptualization of what is a perch pond, right? They're asking, maybe we can pull up that image, but they're kind of asking, like from a cross-section view, would it look like a muffin, or what would it look like? Kind of like a plateau, huh? A cross-section.
Yeah, like a mesa, kind of, right? So let's see if
like a mesa, yeah.
If I can find a proper place to find that image for you. So I'll show you what I can do is go to the HVO. This will be real quick, and then we'll wrap it up here.
All right.
And we'll go to the latest information, and we'll go to the photo and video chronology. So one last thing, Nathan, is the best example is 1924. And 1924, lava came back in 7 times over 10 years, lasting between 2 days and 33 days, long eruptions. And so, this eruption is still within a ballpark of the one example we have, a good resolution, 33 years. Going back in time, we might have had other collapses. It's hard to really have the data, the resolution of how the supply rate was compared to now, and so that's kind of all we have to go back on. It could refill more continuously, more quickly. We'll have to wait and see. That's the kind of the charm of watching it. It's okay. I think I'm back here to January 3rd. Was it when we were talking about this, Dane?
Yeah, I believe so.
Yeah, here we go. So
maybe the second.
Birch Lake rising in Pu'u'o, and there it is. So that's what it looked like in Pu'u'o. So you can kind of see. I'm going to try to draw a cross section right here, right? So this is the crater wall comes up. It's not quite that steep. It's like this. Crater wall comes up. It drops in. Crater floor is flat. When you get to this edge, it rises up. Then it's kind of flat through here and elevated. And down here, it goes back to this level. And back over here and back at this other end, it'll go back up from the other edge of the crater. All right, so there's a profile view of that kind of perched lava lake in this particular photograph. In the case of the current Hale Mau Mau vent, right, we have the vent going down, and I want to draw the very bottom of it. But something like that. And you have that surface going like this. Right, so that's kind of the shape of the bottom of the vent now. Something like that. And so it can spill over into those little trenches on either side. Not unlike what you see in this photograph right here. All right, so thank you guys for the questions. We know there's other important things happening tonight. I don't keep you too long, so you can get to us in the comments and chat. We'll back with you guys one more time here by the end of the week, and kind of summarize what's been happening, maybe in a little more detail. Anything else you want to add, Dane?
Nope. We'll try and get. There are still some good questions that came in at the end, so we'll try and get to those in text, or maybe save them for next time.
All right, sounds great. Thank you guys.
All right.
So, for myself, Philip Ong, and Dane DuPont, on behalf of Hawaii Tracker, mahalo, you guys.